Everyone, let's do the revision of two chapters today. That is chapter number 3. Let us start with the chapter number 3 first. That is atoms and molecules. We will do such revision for the other chapter also. And for the word problems, we'll see. We'll try to manage something for the same. Okay. Let's see if we talk about atoms and molecules. Okay. If we talk about atoms and molecules, uh, please understand that whatever things we've been highlighted, try to remember those highlighted things because that is the one which is helpful to us. Okay, fine. See the first one. As what I said, Maharishi Kanath, right? He gave us the word Pardarth, then Parmanu, right? That was further given as he named these particles as Parmanu. Padarth is made up of Parmanu. Indian philosopher Pakuda Katyayama, what he said, right? He said normally matter does not exist in a free form. Then Democritus and Lucifer's came. They gave actually the word atoms means indivisible, and finally Antony L. Lavoisier, he gave us two things. He gave us two things: law of chemical combination. In that, the first is law of conservation of mass. That in a chemical reaction, mass does not uh, get added or either get used. So basically, before reaction and after reaction, the mass is going to remains constant, right? That's what the mass can neither be created nor destroyed in a chemical reaction. Constant proportion means what? That always two elements, they always mix in a definite proportion by mass. So for example, 9 gram of water we need to decompose, it has 1 gram and 8 gram of water only. So basically hydrogen and oxygen in water, they always mix in the ratio 1 is to 8. Now this cannot change. Okay, so that's what the second law said by the Prost, that in a chemical substance, animals elements are always present in a definite proportion by mass. Other important thing is Dalton's atomic theory, right? So basically Dalton has given us an atomic theory that atoms are indivisible, right? That can find which cannot be created or destroyed. Atoms are identical in mass and in chemical properties. Atoms of different elements have different masses and chemical properties. Atoms combine in the ratio whole numbers to compounds, right? So we have to remember all this property, right? So this are the question. Now atom, right? We know atom is indivisible. Normally they used to ask atomic radius. 1 nanometer is equal to 10 raised to minus 9 meter. But if in a reverse way they ask 1 meter is equal to 10 raised to 9 nanometer. Remember, don't get confused here. Third thing is, what are the modern day symbols? These are the symbols they used to use it. Now, as what I tell you, these symbols or names, how do they come up? Either the name have we come up from the place they were derived, for example, copper for Cyprus, or that is the color. Therefore, gold is used for the yellow. IUPAC full form you need to remember: International Union of Pure and Applied Chemistry. Okay, but many of the symbols are derived from the first letter, but sometimes the first letter is same. They used to use a second letter, but make sure the first letter is always written as capital and the small second letter is always written in the small. As you can see here, aluminium is AL and not A capital L. Okay. The other thing is some names are came from Latin, German or Greek. Iron is like Fe from ferrum, sodium, natrium, potassium, kalium, right? Like this. So some names comes like this, some names in the other way around they used to do. Atomic mass. Now atomic mass is, but how do you find out the atomic mass? So first of all they have taken oxygen, then they have taken carbon. But when we talk about atom, the unit can be first represented as AMU, but later on it is given by IUPAC as U as a unified mass. Remember such symbols, okay? We have to remember all these symbols. Now, atomic mass is given as the mass, one atomic mass, if you see here, one atomic mass is the mass of a unit exactly equal to 1/12 of the mass of a carbon 12 isotope. Remember this thing, okay? Now, How do atoms exist? The atoms do not unable to exist independently. They are always there in the form of molecules or ions. Then what is a molecule? Then you know molecule, two or more atoms combined chemically together by an attractive force. We call it as a molecule. Now molecule as what you see. Sometimes there are molecules which combine with atoms combine with itself to form a molecule. Oxygen, argon, helium, right? Like this. And sometimes they will form combine, right? Which we call molecules of some compound. Ion is what? After, right? There are certain compounds, even though they combine, still they have charge. That we call it as an ion. This charge are called ions. Ions are of two types, cation and anion, right? Positively charged we call anion, and positively charged we call cation, and negatively charged is a anion. Then we learn chemical formula that is depend upon the combining capacity. So basically you need to remember this thing, which has plus 1 charge, which has plus 2 charge, which has minus 1 charge, which has minus 2 charge, and whenever they combine they cross multiplied. But remember one thing which I told you here, what if both have the same valency? Let me show you an example. If both have the same valency, as you can see in calcium oxide, this cannot be C2O2. This can be CaO only, because both of them have the same valency. You can only do this thing when the valencies are different. So understand this simple logic here. Okay. So that is how the structure, and that is how we need to work. Understand a very simple logic here. This is how they'll cross multiply, and that is how you'll get the answer. So name, chemical formula, the molecular formula. Molecular mass, you simply have to add the atomic mass and you'll get the molecular mass. Clear? So this is how you'll get the molecular mass. Formula mass unit is same only, but that are used for a compound, right? Formula mass unit, same everything, there is nothing. Mole concept. Then mole is what? I told you there are certain number of atoms, right? Or a group of atoms, we call it as a mole. Now mole is what is what? 1 mole is what? If we talk in terms of gram, if it is atom, it will be atomic mass. If it is molecule, it is a molecular mass. If it is ion, it is that mass. But if you talk about 1 mole, the number of atoms or molecules remains the same. If we talk about atom, it is 6.022 into 10 raised to 23 atoms. If we talk about molecule, it will be that many molecules. Understood? So gram is atomic mass, molecule is molecular mass, and in terms of number you have to talk like this. Clear? So remember, this is called Avogadro's number, and it is find out a name under the honor of Amedeo Avogadro. Okay, and what is the mole introduced first by Wilhelm Ostwald, which we name as heap or pile. Okay, then this sums. Okay, there are two formulas as what we learned. Small n is equal to small m upon capital M, and small n is equal to n by n0, and these are the one. Small n is called moles, m is a given mass, m is a molar mass, mole is a molecular mass, right? Number of particles is given as capital N, and Avogadro's number as n0. Okay, so definitely in the sums, if there is any element is there, for example, if like P, see they have given the atomic mass of phosphorus. Likewise, if there is any sum, I will give you in sum only. I am going to give you the atomic mass or of element, not molecular mass directly. I will give you the atomic mass, carbon, oxygen, nitrogen over there, if in a question. Okay, so just revise it properly. Update me if you still don't know anything. I'm going to help you. Please send me a personal message. Structure of atom. Now I told you. Then the race started is how to what is the structure of an atom. Now, but before electron was identified, J.J. Thomson, E. Goldstein discovered, right? E. Goldstein discovered a positively charged, which are called canal rays, right? Which we call it as protons. So, electron was identified J.J. Thomson, proton was identified E. Goldstein. Both are represented, proton is represented by P plus, electron is represented by E minus. Okay. This is also you have to remember, the mass is approximately 200 times that of an electron. Then, Those are charged particles. Structure of an atom. So J.J. Thomson gave us the first model. It's like a watermelon. Well, the red portion gives you positive charge and the seeds gives you electrons. But this model is not accepted. These are the 2 points. Why? It will not explain. It is electrically neutral. Then Rutherford came. He takes a gold foil and he bombarded the alpha particles, right? 1000 atoms thick. And what the result came was very surprising, that one of 12,000, there is one particle which rebound. This is like throwing a stone on a tissue paper and the stone will rebound. Okay, so this is what it is. He will, right, and this is what he concluded. What he concluded, that positive charge is at the center, which we call it as a nucleus, and the mass of an atom resides in the nucleus. Electrons revolve around the nucleus, and the size of the nucleus is very small as compared to the size of the nucleus is very small as compared to that. Okay, so this is what they understand, and this is what they have told you. Understood all? Now, drawbacks. Drawbacks is what he concluded is this, that electrons slowly lose its energy and finally end up into nucleus. See, the revolving nucleus will lose energy and finally fall into nucleus. This will make the atom unstable. So Rutherford model is also unaccepted, and finally Bohr gave us the model. What is that? That he had divided into shells, K, L, M, N. Center is the nucleus, K shell, L shell, M shell, N shell. K, how many electrons does a K shell have? 2 electrons, right? Why? You have to remember the formula 2n square, right? Now K shell is n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4. Those are called orbits or energy levels. These are called orbits or energy level, right? These are also called orbits or energy levels. Now, clear? Then the neutron come into existence. They say neutron is what? Neutral. They do not have any charge, but it is a mass exactly nearly equal to proton. I cannot say exactly equal to proton, nearly equal to that of a proton. So maximum number of electrons, that we say 2n square, and finally you get 2, 8, 18, 32 like this. Maximum electrons one orbit can accommodate is only 8, right? After that, first of all inner shells get completed and then the external. Valency is what? The number of, see, there are two things. One are called valence electrons and other is called valencies. Valence electrons are those which are there in the outermost shell. Whatever electrons are there in the last orbit are called valence electron, and the number of electron donate or accept is called its valency. Okay, this is called atomic structure, dot structure. Okay, so this is how we will find out valency, right? 8 electrons octet, the number of electrons gain or loss or shared, or we simple in language we can say combining capacity, we call it as valency. That is, we call it as valency. Understood? Now, the atom of each element has definite combining capacity, we call it as valency. The mass is defined as sum of the total. Now, how do you do atomic mass? Atomic mass is number of protons plus number of neutrons. Electrons has nothing to relate it with it. So, it is represented by a letter capital A. What is Z? Z is the atomic number. And this is the way it should be written. So, you should understand what is written at the top and what is written at the bottom. Atomic number Z, right? Mass number, that is as what just explained, number of protons plus number of neutrons. Isotopes, what? Isotopes are those which has same atomic number but different mass number. Again repeating, same atomic number but different mass number. So definition can be asked from this, right? And isobars are different, same mass number but different atomic number, right? Mass number is same and atomic numbers are different. You have to remember what are the applications of isotopes. Okay, so understand this simple thing. All questions you have to prepare, and if you have any doubt, again feel free to message me that I'm not getting this or that. I will help you accordingly. Thank you so much.